Hello everyone, in this video I'm going to solve this example. Um, it's a initial value problem with this initial condition, and of course don't get caught up in it's x not y, doesn't matter. The dependent variable here is x, so we're looking for some x solution, so it's important to understand that before we start. Some x solution, right? And the independent variable is t. So we're looking for something like this. And as you see here, the right-hand side is dependent on t, which is fine. We have uh, the the dependent variable x in this left side, which is fine. It's not like x squared. And we have this kind like coefficient times this derivative. It's also dependent on t. So it is linear equation or linear differential equation, and we can go ahead and set it up. So the setup is to divide by t squared, and you get dx by dt, this derivative. And so this is just the prep. And after, of course, you divide by t squared, you want to simplify a little bit because it looks like we have a bunch of t's here. Yeah, I picked this example because it's going to have a lot of things going on, but that's what we're doing with math is attention to details and double checking the steps. Okay. So that gives us now, once it's in this form, it gives us the, let's do it a different color here. That gives us p of x, which is a positive 4 over t, and that will give us to find the integrating factor. So here the independent is t, so dt, not dx. And just replace. And next, and here the idea that you have a 4 and a 4, so we've done this now a few times, and that's going to give you this, and these two will cancel, and you get mu to be t power 4. Okay, let's write it here. The integrating factor is t to the 4th power there. Okay, next step is to multiply this equation by mu. Okay, so t to the 4th by the derivative plus 4t to the 4th over t times x equals to t to the 4th times the left hand side. So that's why it's good to write as you do this. So as we go to the next page, you have your step written down, and you multiply yourself by t to the 4th and see what you get. Then match it to this, right? So even if I forget something, you're gonna see it as well. So it's good for you to keep writing as you go through the problem. And we know here we built this product rule. Of course, you can simplify this, and you will see that it's the derivative for t cubed right here, and you'll see that it's the derivative of t to the fourth. But if you get to this and you've seen other videos, you know directly that this is just going to be mu times the dependent variable. And the integration here for this right hand side. Um, I think before that I try to go, let's, not yet, trying to go ahead, but no, let's keep it this way first, then integrate and remove. I was gonna write then cancel, shows like strike this, but let's just keep it this way, then do the next step, which is to integrate, which is now this is released, and you do all right. Once you do this, you know that for the right hand side you want to integrate each one by itself. Okay, and now this one is easy, the second one. So this one here is to do, let's do different color, integration by parts. Okay, so u is, let's say, natural log of t. So du is 1 over t dt, and dv is going to be t to the fifth dt, which means v was t to the sixth by 6. Okay, so now the solution to this integral is going to be uv. So that's why it's good to write this and pause the video, because you will need to now do the uv minus v du. Okay, that'll be next. Just this integral, so let's call it I, right? Let's just do I for now. So I is going to be uv minus the integral for v du. Which gives this. Okay, so now we can go ahead and put all this into the equation, which means now let's put I and put everything else that's there, and also figure out the integral, which we know. So also you have on the right side, this is not a big deal. This is it's a square. And so that's going to be t cubed by 3, and you have a 2 there, okay, for that one. All right, so let's put everything together. We have on the right and the left side this, and now you have for this I integral, and this integral of t to the fifth by 6 is going to be another power. We have a 6 and we need to divide by 6, so it's 36. Then now we follow it with this also here. All right, so as I mentioned at the beginning, we're looking for x. So we're going to need to divide by t to the fourth. All right, so divide by t to the fourth will give us, this simplifies by 4, and we get this here. And this also simplifies by 4, and we get this here. And these 3 are out, and we have 1t left. And this does not have any t, so the 4 t's are at the bottom. So that's a general solution. Okay. And now, since this is IVP, we have an initial condition that says x of 1 equals 0. That means 0 is here, and t is 1. Okay, so here I'm going to do 1/6 natural log of 1, which is 0. And here 1 over 36, and here 2/3, and here c over 1. Okay, so figure out this value, and that will give you c to be negative 23 by 36. So the particular solution for this problem is t squared by 6 times natural log of t minus t squared over 36 plus 2 over 3t minus 23 over 36t to the fourth. Or you can choose to make it having a negative exponent. All right, so I can see where this question, there are places for error, but it does teach us attention to details and working on something and bringing it to the problem, which you may need to do. Let's say, for example, if you do programming and you have subroutines, and there is a main thing you work on, and there is other sides that you need to work on as well. And at the end, you verify everything. Thank you.